Speaking of use cases, so I work in AI, and I have 4 different ways I work in AI. And I think it's important for people to separate these layers because all of them need different skill sets, different strategies, different time investments, different money investments. So you want AI, all of you, but you want to know exactly which layer you belong in and what kind of stuff you need. So I'm gonna just mention them very fast. I'm gonna start from the bottom. It's like always in the bottom. There's always the real life use cases, like exactly what real life projects that affect your business and align with your mission. The most important thing for me here is that the project is implementable, and whatever we end up doing in real life does not go to wasteland. Because for me, time and money is the most important, and I've seen so many people work on so many things that go nowhere, and the way we do it here is we do it very different. And then part of the way I work in AI also is understanding the foundational models, which is all of them are in my book. But these models appear and die every day. Every day someone's doing something different, using a different function, using a different loss function, training different data sets. So they change a lot, but the principles are the same. So we focus on the principles, and I also focus on these models, standalone models, and how they integrate into systems pipelines, because these are also different. Do you apply this model to this one data set and do something with it, or are you integrating it into your whole pipeline, and how you use it? And then at the higher level than that is the interface of AI and data infrastructures, and at all levels of an institution or company. And then the very, very top level is the AI and data strategy at the institutional level. So if you look at this from bottom up, it's like the need that's driving the AI use. And if you look at it from top down, it is the strategy. It's a top level strategy, AI or data strategy that's pushed down at all levels of your institution. So these are not like fully isolated. They are separated, but are not like isolated, because knowledge of one informs the other. So they do inform each other. And the underlying principle is that that we have processes, and for some reason we're not happy with them. Most of the time we want improvement, and we want to automate our processes. So that's basically what drives progress at all of these levels. So at the very bottom level, the real life projects I work with, these are just consulting work. We get projects from all kinds of entities. Some of them are the military, some of them Department of State, some of them are fire department, transportation department. But usually what I've noticed that's common with all of these is they all come with very similar problem. They all have problem with their data, and they want to do more insights. They want to upgrade some processes. What I've noticed that works, because we've delivered on all of these projects in very short amount of time. So as I said, implementable is so important. So one of the most advice I give people here is that to talk to stakeholders at all levels, talk to the people on the ground, talk to the Marines, but also talk to the Assistant Secretary of State, talk to everybody in between, and see whether what you're proposing is implementable, or if people are doing it already. And it's good to use existing technology and build on it, as opposed to just tell them destroy everything and do it all over again, because there's resource constraints. Expect to not have data available like Anis, and it's like it's what you said today was so common, and I see it all the time. Like, you have to sometimes work without data, and you have to innovate, and you still need solutions. There's red tapes of all kinds of things. There's some people, like, your solution is gonna threaten their entire department, so there's a lot of politics involved. So in real life projects, if you want to see them into delivery, you have to follow this process. And then some bragging rights, just to give some credibility to what I do. These are our students presenting to Assistant Secretary of State and all of his, for Diplomatic Security Services, and all of his deputies and directors for 4 hours, and at the fire department. So all of this is super cool. Whereas I'm speaking at the GTAC conference. This is like the federal federal government in the U.S. All the information technology chiefs and all of that. So it's really cool. But that's because like we do deliver eventually. And I'm also speaking at the UN General Assembly in the science. So in case you were wondering, we do deliver and we do have some value. But what I do notice is that usually there's three big continents driving AI, and there are the US and Europe and China, but there's the whole rest of the world. So we give courses in South America, for example, and there are other people all over the world. That's where your opportunities are. So do connect with these people and do find opportunities. Everybody wants AI. AI does have potential, but you have to like make the connections and see what exactly their use cases are. So my second level is the foundational models. So these are, as I said, standalone and how they integrate into systems pipelines. So in what I did in this book and what I always preach is that all these models, like you were telling me this morning, that they seem different, but in general, they're doing two simple things. They're either deterministic models or probabilistic models. You're either learning a deterministic function in each one of them, or like linear regression or nonlinear regression, or a neural network, or you're learning a probability distribution, and what your assumptions on these probability distributions are different from one model to the next, but it's all understandable. So if you kind of separate it into input, output, linear, nonlinear mapping, if you separate it in your head that way, you should be like very good and seeing it all from above. And then the next level is the interface of AI and data infrastructure and all levels at value of supply chain. This is the part where I didn't know anything about when I was writing my book, and I ended up spending a lot of time. I realized I had a gap in that. I didn't understand what happens before the stuff that I use, and I decided that that's the stuff that I needed to learn. So I'm basically with the right crowd here, so I feel like that's what you do. So I was here. So AI stands on all of this. It stands on data engineering, software engineering, the hardware that goes into you need all of this, and you need the models. So I was here and I wrote a book about AI, but then I spent the whole year trying to understand exactly what the rest is, because you really hit a wall in your knowledge. You cannot answer people and advise them on what's going wrong if you don't at least have, you don't have to be an expert with all of this, but you should have an idea of where things can go wrong. But AI doesn't only stand on these pillars, it also enhances them. So AI can help the material design for it. It can help, I mean, there is a feedback loop here. So all of this helps each other. So the more, and then one thing is, if you're doing AI coming, say, from any of these pillars, you run the risk of reinventing the wheel, because you don't know that there are hard-learned principles and hard-learned lessons that others have already done. So you do want to know to collaborate with people who are have a specialty in this, because you don't want to redo their mistakes when you're trying to solve problems. So again, talk to people at all levels. And I noticed that most of the stuff is like you have input, and you have stuff that happens to the input, and then you have output. For example, for data engineering pipelines, that's from you, Joe, it's a whole mess of data sources and then data engineering pipelines, and you have pretty data in the output ready for dashboards and analysis. Or you have a LinkedIn post, and then you have a machine learning model that classifies your LinkedIn post, and then you get a label, and that label triggers some action. So if you think of things as input and output, then a lot of things come together nicely, and you don't have to feel like you have to learn so many things you don't know. And then I noticed that a lot of people treat machine learning as this like this separate entity that they don't know anything about, but in reality, it's just part of the pipeline. It's just a function. You change a function, input, output, and you kind of learn it. So I wouldn't treat machine learning as separate. It just succeeded recently, but it's just one more thing to learn that is not. Your machine learning engineers don't have to be separate than your other engineers, and they're speaking different language. There is a common language. That's my point. And then at the very top level in my triangle this is my favorite. It's the AI and data strategy at the institutional level. It's my favorite because I end up talking to the people at the top, and it's so good to talk to people who have the power to affect change. That's good for a change. And it does help me understand like the institution. For example, this is our institution at the university, and we're trying to implement AI and data strategy at the whole institution. Just to help you understand our institution, we have 22,000 students, we have 1,400 faculty, 2,900 staff, and we have 139 programs. And we're trying to redo the whole ERP system, and we're trying at the same time to implement data democracy and data governance and AI strategy. So that is a huge project. I'm learning a lot in that project, but there's always moving parts. Institutions are not static. For example, as we were thinking about this, a whole division came up from here all the way to report to the president as opposed to report to the provost. So all of their reporting structure and data flow and authentication, all of that changes. So we have to like have data models or whatever that accommodate those kinds of changes. But then this AI and data strategy at the institutional level gives me a full loop back into math and explainable AI. So because part of when you're working at the institutional level, you have orders from the governor that you have to comply with. You have, for example, here you have your European Act. In Virginia, we implemented the governor implemented the first AI directive in all of the US, and I'm sure a lot of states will follow suit. So in that sense, we have to document everything. We have to also make our AI explainable. And then we have to think, what does explainable mean? And all of that. So in order to implement this strategy and make it compliant and with regulation and auditable, like yesterday with Benoit, we have to know what explainable AI means, and then that brings me back to math. And so if you think about AI, it's always representing high-dimensional data with lower-dimensional vectors. Like you have data of all types, and all you're doing is you're doing embedding vectors, and then you're doing decisions or calculations with these vectors. So how you move from data to vectors could be linear, easy to explain, or nonlinear, which is more math to explain. But in the end, you're not doing anything but that in any of AI models, right? So for example, convolutional networks for images, they move from images to a vector, and that is in a nonlinear fashion. The nonlinear fashion is the actual convolutional network, the function representing it. But then here is just a convolution operation moving from an image into something that you see the horizontal lines. That is a linear map. I can convince you later. But it isn't that much different, right? It's either linear or nonlinear. And if you understand that, you can explain a little. So in linear, you can always explain more about your models, how every input feature affects the output. But in nonlinear models, for example, then you have to like do more math. But that math is doable, and someone needs to sit down and do it. And that's my next steps. And so what are the essential components of explainable AI? That is what I'm working on right now. You have to understand the models, the data, the deployment use cases, and the limitation of each of these models. And then you have to understand the exact contribution of a point attribute to the embedding dimension if you want like your models to be explainable. And you have to understand the pipeline from the data to embedding to a decision. It's important to know if your AI is making decisions, you have to know how that pipeline worked, and you have to quantify and report uncertainty with the model's predictions, and you have to quantify causality and correctly model logical reasoning. So a lot of people only talk about correlation, but if you want your AI needs to reason and say, I made this decision because of that. And just observing the data is not enough. You need to do more mathematically. You need to quantify observing and make it different than intervention, and make it different than had I not done this, what would I have observed? So this is how humans reason, and this is, all of this can come together using explainable AI. That's what I'm working on next. So basically, my advice to you is dive into what interests you and has and brings value. You have to understand, like, you have to start with what is the value, what's the use case, and it actually gets you places, is implementable. And it's okay to question how people do things now and why have they been doing it this way. And if it's not working, just drop it and do something else. We do have an opportunity. I see a huge opportunity. First of all, there's a ton of investments. The entire governments are investing in this. Every single entity I talk to is doing this. So all of you have a lot of opportunity, but we have to do it like thoughtfully, and there's a lot of improvement. So this is the foundation, in my opinion, of AI and data. There's a hardware, there's modeling, communication, data, and there's at the top level the enterprise and data strategy. I can dive into all of these, and I can dive more into this if you want to ask me afterwards. And this is it. Thank you.